Hi, my name is Edwin. Today I'm presenting our research development on a proposed deep learning algorithm that we think could potentially aid architects in early design stages, specifically in the process of design ideation. Architects and designers often communicate their ideas through visual imagery, such as sketches. New ideas emerge as they produce sketches and revise them repeatedly. A fundamental characteristic of these early concept sketches is their ambiguity. The deciphering of ambiguity is a cognitive process of higher order. Higher order cognition allows humans to understand abstract concepts from sketches. Therefore, for computers to be helpful in the very process of design ideation, they must be capable of higher order cognition. Deep learning is an emerging sub-branch of machine learning in artificial intelligence that is capable of learning higher order features. A new deep learning algorithm is developed here to imitate the cyclic visual reasoning process of sketching based on the conditional generative adversarial network. Drawings and imageries are intuitive forms of communication and recording. The lack of conventions and the unrestricted grace of abstractness are the reasons why architects tend to rely on external representations in forms of sketches and diagrams to assist the design process. These external representations are not merely memory aid, but a form of visual or spatial reasoning. Architects discover visual clues from their sketches, which inspire them to make further iterations that often leads to new ideas or design solutions. Sketching is therefore a cyclic process of imaging and abstracting. The objective of the conditional generative adversarial network is to generate novelty images based on an input images as a condition. Therefore, its primary application is for image-to-image translation. The pix-to-pix cGAN is an extension of cGAN with improved loss function, which has been successfully applied to a wide range of applications, such as label to photograph and sketch to paintings. Therefore, pix-to-pix has been adopted to develop the machine learning algorithm in this paper to imitate architects' cyclic sketching process. As mentioned, sketching is a repetitive process, and each individual sketch contributes to the overall transformation. Constant exchange of abstraction and imagery facilitates transformation, and new ideas subsequently emerge from such cyclic process. This cyclic process of visual reasoning essentially involves two steps. One, to transform sketches into images, and the other, from images back to sketches. In this paper, a novel machine learning algorithm to imitate such cyclic process based on cGAN is proposed. The proposed machine learning algorithm, referred as cyclic cGAN, consists of two cGANs, one for each respective step. The sequences of results generated by the cyclic process would show how the original sketch is gradually transformed. The training of cyclic cGAN is as followed. So first we prepared 84 sets of manually produced sketches from selected images, as shown on the diagram. Color code is used to identify different materials. And then we trained the first cGAN to translate sketches into images, and we then trained the second cGAN to translate images back to sketches. Ambiguity is essential in discoveries and transformation. Hence, the input sketches of the experiment should be foreign and ambiguous to the cyclic cGAN. For this reason, black and white line drawings are used as input to cyclic cGAN. The workflow of the experiment is as follows. We use the first cGAN to generate the image from each of these sketches, and then the image generated by the first cGAN becomes the input for the second cGAN to generate new sketch. The new sketch generated by the second cGAN becomes the input to the first cGAN to generate a new image. So repeating step 3 and 4, this process mimics the cyclic process of imaging and abstracting. Here are some of the results from the experiment. As illustrated, the cyclic cGAN appeared to be searching for clues during the initial phase of iterations to formulate an understanding of the input sketches. Due to the ambiguity of the first imagery, some features of the input sketch are either distorted or omitted from subsequent iterations, resulting in a change of spatial relations. These new relations give rise to new meanings, and through further rumination of imaging and abstracting, the cyclic cGAN concluded with a more definitive shape. The red dashed line highlighted the features of the input sketches that the cyclic cGAN attended to and developed the further iteration upon. It is also observed that the cyclic cGAN can identify skies and surroundings, although no such feature is articulated in the input. Also, continuities in color and form, foreground and backgrounds manifest during the iteration process. In summary, the iterative process of the cyclic cGAN is comparable to architect's cyclic connective process of interpreting and abstracting. In the first iteration, the cyclic cGAN interprets the input sketch by isolating, removing, and regrouping features in the input sketch. Consequently, the original sketch is transformed based on these newfound relations. Cyclic cGAN's ability in interpreting ambiguous sketches through this iterative process could assist architects in visual reasoning. By removing or highlighting sketched features, cyclic cGAN could encourage architects to find new meanings in their sketches. Further, cyclic cGAN could generate images that could provoke architects into seeing their previous sketches in a different perspective. With the cyclic cGAN, we propose a possible way of utilizing computers to assist architects in design ideation. Thank you.